All right, on the warm up on problem number 1, what I like to do is just kind of separate my coefficients. So -5 is going to be cubed. So that's -5 times -5 times -5, which is -125. And then x to the -4th raised to the 3rd power. When you have power to power, you multiply the power. So that's going to be x to the -12. So it'll be -125 x to the -12. But it says simplify using positive exponents. So remember what we're going to do in order to change that -12 to a positive 12. We're going to take x to the -12 and move it to the bottom. So your final answer would be -125 divided by x to the positive 12th power. Problem 2, you're going to take both the numerator and denominator and cube it. So it will look like 2 cubed divided by 3 cubed. So 2 cubed, 2 times 2 is 4, 4 times 2 is 8. And 3 cubed, 3 times 3 is 9, 9 times 3 is 27. And that's not going to be able to reduce anymore. So your final answer would be 8 over 27. Let me go ahead and box these in so you can see the final answer. Number 3, again, you're going to take all the numerator and raise it to the 4th power and all the denominator. So this would look like 2x quantity to the 4th power all over 3 to the 4th power. So basically that means 2 to the 4th times x to the 4th. 2 to the 4th, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, x to the 4th. Okay, so that's all in the numerator. The denominator, 3 times 3 is 9. And then you have another 9 because that's two nines. So 9 times 9 gives you 81. And 16 and 81 don't have anything in common other than 1. So your final answer is actually that. I'm just going to go ahead and box that in right there. On number 4, let's see a few things we can do. We can take this negative exponent and move it down below. And in the denominator, y to the 0 power, that's basically just 1. So we can just kind of cancel that out. So another thing is, I don't know if you can see this, is that 4 and 8, 4 divided by 8 is 1/2. So we can go ahead and make a 1 there and a 2 there. All right, so let's kind of see what we have left over. So we have a y cubed in the numerator. And then in the denominator, we have 2. And we're bringing our x to the -6 down. So that will become x to the +6. And then we have an x squared down there. All right, so let's see what we can do with this. Looks like the only thing we can do is combine our exponents with the x's. So our final answer is going to be y cubed all divided by 2x to the, when we multiply with the same base, we add the exponents. So 6 plus 2 gives us, so that would be our final answer there. All right, let's take a look at number 5. The parentheses just basically shows you that we're going to multiply. There isn't any power raised to the outside. So basically what we can do is multiply 2 times 4 and get 8. And then we can add the exponents of our x's. So 3 right here and 5 there. 3 plus 5 gives us 8 all over x to the 10th power. So remember, we want to write this using positive exponents. So think of your expanded form of x's. If you have 8 of them in the numerator, 4, 5, 6, 7, 8, and you have 10 of them in in the denominator, all 8 will cancel out in the numerator and the denominator. So you're only left with 2 of those x's in the denominator. A shortcut would be subtract these 2, 10 minus 8. The remaining amount will be in the denominator. So your final answer would be 8 divided by x squared. All right, let's take a look. Let's move this up a little bit. Take a look at problem 6. See what we can do with that. Since you do have a power on the outside, the best thing to do is go ahead and multiply power to a power. So this will be x to the Negative 2 times 4 is negative 8. Y to the 4th power all over x cubed. Y 2 times 3 is 6. All right, so what we can do right now is take this x to the negative 8, and we're going to move it down to the bottom. So we're left with y to the 4th on top. All over, we have x to the 8th. And it's basically, when you move that down, it's going to be multiplied by x cubed, and then y to the 6th power. So now what we're going to do is we can add the exponents of our x's. So 3 plus 8 gives us 11, and that's going to stay in the denominator. Now our y. So just like before, it's like having 4 y's on top and 6 y's on the bottom. So all 4 will cancel out, and you're left with 2 in the bottom. So we're going to have y squared in the denominator. That leaves us nothing in the numerator. Well, we need a placeholder. The placeholder is going to be a 1. So that will be our final answer there. All right, number 7. Whoo, this looks hard. However, nice. Everything's raised to the 0 power. Anything to the 0 power is 1. That's our final answer. I know I have a bunch of other stray marks here. That's from my hand. But anyways, your final answer is just 1. So always look for any power of 0, because you know that's just going to cancel out to be a 1. All right, so now let's get into practice graphing exponential functions. It says things you know about the graph just based on the equation. So we know that this pretty much looks like y equals 1 times 2 raised to the x power. So we know that our initial amount is going to be 1. So that's our y-intercept of 0, 1. Our constant multiplier is going to be the number that's raised to a power, which is 2. And since that constant multiplier is 1 or more, we know that it's going to be a growth. All right, let's take a look at number 2. So we have the y-intercept, or the initial amount, is the 2. So we know that's our y-intercept. Constant multiplier is 3, and the constant multiplier is 3, so it's going to be a growth. Number 4, this would be like 1 times 1/2. Y equals 1 times 1/2 raised to the x power. So your initial amount will be 1. Your constant multiplier is 1/2. So since that's less than 1, it's going to be a decay. And this one, your initial amount will be 6. Your constant multiplier is 1/3. And since that multiplier is less than 1, it will be a decay. So those are some things we just know about the graph. All right. So now as we get into this other side, it says to identify the asymptote. That's how you say it. No, I'm not cussing at you. It's kind of like the P is silent. Asymptote. Graph each equation and see where the graph levels out horizontally. So it's like y equals some number. So asymptote is where the graph levels out horizontally. Also look in the table to see if the y values round to a whole number. Some may just be written in scientific notation. So we can put this in your calculator, y equals 3 raised to the x power. And this will give you a point, pin 0.001. To the negative first will be a 0.3 repeating. To the 0 power is 1, 3, and then we have 9. So then if we go over here and we graph this, so a negative 6 and 0.001 is just barely, it almost looks like it's on the line. And negative 1 and 0.3, so negative 1 and 0.3 will be about right here. 0 and 1, 1 and 3, and 2 and 9 is right there. So this is what it's going to look like. Oh, I messed up right there. There we go. Okay, so the asymptote is going to be basically where it levels out. So you see how at -6, it's 0.001. It's never, ever, ever going to hit the x-axis, but it's real close. So we say this is going to be, and it's kind of like you go back and see about where it goes through. So if you look at my graph here, it goes through about where y is equal to 0. The y-intercept, of course, is 1, because remember, this equation is like y equals 1 times 3 raised to the x power. All right, let's do a different color. Let's see if this is a hot pink. Okay, so we have 3 to the x plus 4. Now, this is a little bit different because now we're adding something after the constant multiplier. So when x is -6, we have 4.001. When it's -1, it's 4.3. When it's 0, it's 5, 7, and 13. Okay, so let's go ahead and graph this. So -6 and up 4.00000. So it's almost like it's on that. And then -1 and 4.3. So barely. And then 0, 5. And 1, 7. And 2, 13. Okay, so now it's going to go here and look something like that. Okay, so this one is y is equal to 3 to the x plus 4. And our asymptote would be where it levels out. So if I kind of draw a dashed line, it goes through the y-axis at 4. The y-intercept, when x is 0, that y value is 5. Let's go back, and I want to write the equation here. So this one's y is equal to 3 raised to the x power. Okay, now then let's do a green for this one. Okay, so now we have 3 to the x minus 4. So now, since we have a minus 4, it's going to be -3.99. Then -1 is -3.6, repeating. 0 is -3, 1 is -1, and 2 is 5. So -6 and -3.99, and -1 and -3. Right there. And then 0 and -3, 1, -1, and 2, 5. So it's going to look like this. And it will keep going. I'm not going to keep going because my lines don't look that good. So this is equation y is equal to 3 to the x minus 4. So let's take it where it's at its flattest point and kind of draw a line backwards through the x-axis, and it goes through the x-axis at -4. So your asymptote would be y equals -4. Your y-intercept, of course, when x is 0, so that would be -3. All right, so let's take a look at problem 6 and 7 and see what we can do on this here. So 3 times 2 to the x. So you put this in your calculator, and at -6, it's 0.05. And then at -1, it's 1.5. And then 3, 6, and 12. 3, 6, 12. So -6 and 0.05. And -1 and 1.5. And then 0, 3, 1, 6, and 2, 12. All right, so here we go. Not bad. Okay, so this one is y equals 3 times 2 raised to the x power. So the asymptote. So if we take where it is on its flattest part, and we kind of draw a line back through the y-axis, it goes through the y-axis at 0. So it's y is equal to 0. Your y-intercept, of course, when x is 0, so that's 3. Your constant multiplier is 3. And, oops, I'm sorry. So sorry here. Constant multiplier is 2. And then the initial amount is 3. All righty. So let's go ahead and take a look at this next one. You have 3 times 1/2 to the x. So you know, since your constant multiplier is less than 1, this is going to be a decay. So it's going to go the other way. So when x is negative 2, y is 12. When it's negative 1, it's 6, 0, 3, 1, and 1.5, 2, and 0.75, and 6 is 0.05. So when we graph this, so negative 2 and up 12, that's just going to come down. Negative 1 and 6, 0 and 3, 1 and 1.5, 2 and 0.75, 6 and 0.05. So it's going to look like this. Not bad. So this is the equation y equals 3 times 1/2 raised to the x power. So your asymptote. So where it levels out, again, we're going to take the flat part and then just come back through the y-axis. So this one is also at y equals 0. Our y-intercept is when x is 0, so that would be 3. Our constant multiplier is 1/2, and the initial amount is 3. All right, so a lot of this can be done in your calculator, which is a saving grace for some of y'all. All right, signing off.